Now, on the basis of the size of the solute, solutions are classified under 3 categories. One is true solution, other is colloidal solution, and the other is suspension. So, on the basis of solute size, you should remember it that this is on the basis of solute size. This classification is entirely on the basis of solute size, due to which the properties of the solutions changes a little bit. So they are classified under 3 categories: true solutions, colloidal, and the suspension. So first of all, I am going to tell you the example, because when I will be telling you the properties, so you should have an idea of the example which I will be stating. Okay, so that means, yeah, this is just obeying it, so that means it comes under the true solution, like that. So the example of true solution is when we dissolve salt in water, right? And the example for colloidal solution is oil and water. And the example for suspension is chalk in water, right? So we have these 3 examples. Now we'll be considering what are the actually difference that they have among themselves. So first is the true solution. You must be familiar. So if you are dissolving salt in water, so when you stir it, you will get a homogeneous mixture. That means the solute particle is too small. So that means in true solution, solute is too small. And when I am considering oil and water, first we'll take up the suspension, because the colloidal solution has the properties intermediate of true and the suspension. So it will be comfortable for you to study first the true and the suspension, and just to make out the then you can make out the moderate properties that lie between the true and the suspension ones. So the suspension ones are those in which the solute size is too big. And in the colloidal one, solute size is between, or you can say it is it is bigger than the true one, but it is smaller than the suspension, right? So that means solute size is intermediate between the true solution and the suspension, right? The second property is that when you dissolve salt in water, you don't get to see the salt particles or the water particles individually. They thoroughly mix in each other. So we don't get to see the solute particles in a different phase or the water particle in different phase. We cannot see even with the naked eye or with the microscope. So that means the solute particles can't be seen with the help of naked eye or by a powerful microscope. They can't be distinguished from the water molecules. But when we talk about suspension, so particle size is too big that with the help of naked eye only, we can see the solute particles. So that means we'll get to see the solute particles and solvent particles separately in case of the suspension. The microscope is not required. Even with the naked eye, we get to see those particles in differently lying in the same solution, right? So when I talk about colloidal, so what happens? We are not able to see those particles with naked eye, but yes, with the help of microscope, we are able to see the solute and solvent particles lying differently, right? So similarly, taking into the consideration the more property, I think it is these properties which I am listing, it's clear in your mind because I have already stated an example and you must be applying these properties to these examples. So I think it is a better way to understand it in a proper manner. So similarly, the third property which we have is that when I pass this true solution through a filter paper, then what happened? I'm telling you that when I pass this true solution from a filter paper, what happens? It passed through filter paper. That means the particles, the solute particle do not get separated. They pass through a filter paper. Or if instead of using a filter paper, I use a semi-permeable membrane. What do you mean by semi-permeable membrane? Semi-permeable membrane is something which allow the selected substance to pass through, and the certain kind of substances are just stopped by the semi-permeable membrane. So, but when we use that semi-permeable membrane in case of true solution, then it allows the solution whole, the solute and the solvent to pass through it. They don't get separated. So that means these solutions solution can easily pass through filter paper, the pores of the filter paper and the semi-permeable membrane as well. But when we take this colloid, the suspension, and we make them to pass through that filter paper, the solute particles are stopped by the filter paper. So that means the solute particles get separated by the filter paper or a semi-permeable membrane. The reason being the particle size is too big, right? And when I talk about colloids, so what happens? They pass through filter paper. That means they are not separated by filter paper, but when we use semi-permeable membrane, they get separated. The solute particles are just stopped by the semi-permeable. They are not allowed to pass through it. So that means they can pass through the pores of filter paper but cannot pass through the pores of semi-permeable membrane, hence get separated. Similarly, we take into the consideration, if I keep the true solution, the solution of salt and water aside for a few minutes, what is going to happen? Nothing is going to happen, nothing is going to settle down. So that means the solute particles do not settle down when kept undisturbed. But in case of suspension, when we keep it for a few minutes undisturbed, what happens? The solute particles settle down. They settles down due to you can say the big size. In case of colloidal solution, what happens if we keep aside? So they also, sometimes they settle down and sometimes they do not settle. That depends upon the different components which we are using in case of the colloids. But maximum of times it do not settle down. Maximum time it do not settle down. And similarly, so what is the nature of this true solution? Homogeneous or heterogeneous? Obviously it is a homogeneous, because definite composition properties throughout. We do not get to see different phases. In case of suspension, it is obviously going to be heterogeneous, because due to big size of the solute, we are able to see that solute particles and solvent particles separated from each other. They exist in a different phase. We get to see the different phases, the different particles existing in the same solution. And when I talk about the colloids, so they appear to be homogeneous, they look like homogeneous, but actually they are heterogeneous, because when we look through a microscope, we can see those particles separated from each other in a different phase. So that means they exist as a colloid. And moreover, you have seen that so many properties, these all properties are just due to the difference in the size of the solute particles. So the main, you can say the logic behind the classifying the solutions into three categories is just the solute size, because they differ in the size of the solute, therefore they are showing the different properties. Sometimes they are passing through filter paper, sometimes they are appearing in a different phase, sometimes they just occur in a one phase. So this is how you classify the solution according to the solute size.